So the review here, please make sure that you guys try your best to do your review. Again, there are 2 calculated questions in your test 3, and the rest of them, like 10 questions in your non-calculated parts. I can tell you the graphing one is the one that costs a lot of points. So make sure you know how to graph a tangent for tangent or a secant, secant and cosecant. So these are the 2 type of graphs you will get in my test. So make sure you do it really well. Anyone have any questions with your tests here? So I think I sent out this information to you guys. If you have any questions, please email me as soon as possible. If you cannot take the test on Wednesday, next Wednesday, please let me know now or as soon as possible, because I won't be around for Thursday. So on November 18 and 19, those 2 days, I won't be in here. I'm out of town. So please, if you have any questions, if you cannot make it to the test, make sure you come and talk to me. And as usual, we will have a 30 minutes at 1:30 to 2 o'clock. We will have a review for the test 3 here. I do have a test on that day and it ends at 1:30. So I don't know how much time. I mean, I might come in like 10 minutes late. So the review is going to be cut a bit short. So I would recommend you guys to please review it on your own on this, the review for the test 3 here. And if you do have questions, talk to me about it. Okay. Anyone have any questions for me here with the test 3? And Calvin, I need to talk to you after class regarding with your test 3. Anyone have any questions here? All right. So if you do, let me know. You got homework due. Your homework due. This is so weird. So your homework due on this coming Wednesday is 6, 6, and 7, 1. These are the 2 homework that is due on this coming Wednesday. And then your 2 homework due that is on the next Tuesday will be 7, 2, and 7, 3. So do not forget that these 2. Usually our homework due on Wednesday by midnight because your test is on Wednesday, next Wednesday. So this 2 homework is due on the Tuesday in this case. Okay, and we will end at 8.6. So that means that your next test or your final in this case will only cover 7, 4, 7, 5, 8, 1, 8, 2, 8, 3, 8, 4, 8, 6. So these are the only leftovers that it will be covered in your finals. Okay, and your finals is not comprehensive. Means that it does not cover the previous material. So it just cover from 6.4 till 8.6. So anyone have any homework questions for me on 6.6? Anyone have homework questions on 6.6? And we still need to cover a little bit on 6.6 today. Anyone have any homework questions? So let's talk about finish out 6.6 here. So last time in question 10, 11, these 2 questions, we are finding the exact value for the sine arctan or cosecant arctan for this value, 3/4 and negative 5/12. In order for you to do this kind of questions, you have to draw the right triangles and let theta become arctan of this, and then you do your SOHCAHTOA. This is where we stopped last Wednesday. So today we will continue to what happens if your sine and your arc is the same. For example, like sine and arc sine or cosine and arc cosine like this. So what happens if they are exactly the same? This is different. So if they are exactly the same, you can actually cancel them out. So because sine and arc sine, they are like plus and minus or multiply, divide, they are inverse to each other. So they will cancel each other off. So you just need to watch carefully with this. So this is still 6.6. So what happens if you have a sine, arc sine, or cos, arc cos, and then usually you have a number here. Okay. And then we got tan, arc tan. So if you have such case, and this is a number, and this number is 0.3 or 1.6 or whatever, they will cancel each other off. Okay, you will get this number as your answer. Okay, you will get the number, you will get the answer in this case is this number you have, but you have to be careful with this number. Is the number that you get here is gonna be depends on your domain of it. So what do I mean in this case is, if you remember the domain for the sine and the the arcsine and the arc cosine, the domain in this case is from -1 to 1. And for our range, for the domain for tangent is all real, arctangent is all real numbers. So what happens if you got like question number 8, where you have sine arcsine of 0.3, your answer in this case will be 0.3. So they will cancel each other off. But you have to figure out the domain of the arcsine. And now the domain of arcsine is between -1 to 1. So 0.3 is inside this domain. So that will be your answer in this case. So as long as they are the same, sine, arcsine, cos, arc, cos, tan, arctan, you can cancel them as long as the number that you get here is inside the domain in this case. For example, when I do cosine arc cosine of 1.1, now these two will cancel. You will get 1.1. However, 1.1 is not inside the domain of -1 to 1, 1 to 1. So in this case, your answer for this case is DNE. So you have to be careful with this kind of inverse trigonometric. If you cancel them, make sure that this number is inside the domain. However, for the tangent, arctangent of -3, again, this tangent and arctangent will cancel, you get -3. The good news about your arctangent here is your domain is all real numbers. So all real numbers means every numbers will take in this case. So this is how we do if you have the sine, arcsine, cos, arc, cos, tan, arctan, you have to look at the domain in this case, and that domain has to be matched with this number given to us. And if that number is not in your domain, then your answer will be do not exist. Okay, and don't forget, these are the domain for that case. Anyone have any questions for this case? Now, this is when you have sine, arcsine, cos, arc, cos, tan, arctan. Now, if you switch them around, the arcsine, sine, arc, cos, and arctan, tan, you can also do that. You will get, now this time is not a number. This time, this is an angle. Okay, this is an angle. So like pi/2 or 3pi/4 or something else. And again, this will cancel the sine, the arcsine and the sine and arc cos and the cos will be angle will cancel. You get yourself an angle here. Yes, this angle for numbers. But then this angle will following the range of it. So don't forget, one is a domain and one is a range. And if you look at the range of the arc, the range for the sine is from -pi/2 to pi/2. The range for the arc cosine is from 0 to pi. And the range for tangent is pi/2, -pi/2. But this one is in parentheses. So there's a little typo on here. So make sure you take the equal sign out from here. The reason why is because that is your asymptotes. You cannot be exactly negative and positive pi/2 for arctangent. So you have to follow the range in this case. Now, this one is a little bit tough. Okay, so again, you can cancel the tangent and arctan and tan, but make sure you follow the range in this case. So for example, in this case is number 9. So if you look at number 9, we got the arc cosine of cosine 7 pi over 2. Okay. So what happens in this case is your arc cosine and cosine will cancel. You left with 7 pi over 2. However, if you look at your cosine range has to be between 0 to pi. And 7 pi over 2 is not between 0 and pi. So you will have, and a lot of students think, oh, because this is not inside this range, something like your domain here, since they are not, then your answer is DNE, like this case, you know, because like the other case that we have here, because the number is not inside this domain. So your answer in this case is DNE. But however, in this case, your answer is not DNE because we do have an angle that represents this 7 pi over 2. So this is a little bit tricky here. Okay, so the range for this arc cosine to sine is from 0 to pi. Okay, so from here to here, this is what we have for the range here. Now, where is 7 pi over 2? Can someone tell me where is 7 pi over 2 in this unit circle? Where is 7 pi over 2?
Is it in the first?
It's not in the quadrant. So from here to here is pi over 2, right? It's 90 degrees. From here, then you go 2 pi over 2, 3 pi over 2, 4 pi over 2. 4 pi over 2 is 2 pi. 5 pi over 2, 6 pi over 2, and then 7 pi over 2. So 7 pi over 2 is actually this value. Okay, can someone tell me what is cosine of this 7 pi over 2? Can someone tell me what is the coordinates we use for this value here? It's 0 and negative 1. What is the cosine of this? 0 or negative
1? 0.
So we know that this cosine of 7 pi over 2 is 0, right? Can someone tell me another angle will also give us 0 for cosine? Which one?
90.
90 degrees, yes. At 90 degrees, this will be also 0, 1. So your cosine in this case is 0. So the reason why this is not 7 pi over 2 is because it is not given us in this range. So the answer in this case will be pi over 2. And the reason why it's pi over 2 is because it is in this pi over 2 or 90 degrees is in 0 to 180 or 0 to pi. So this is your answer for the arc cosine of 7 pi over 2. So be careful with this kind of value, that we're talking about. So let's do another one. Arc sine of sine, let's say 3 pi over 4. Now the sine and arc sine will cancel. What we left here is 3 pi over 4. But if you look at this arc sine range, 3 pi over 4 is not between pi over 2, negative to positive pi over 2. So you have to tell me what is the same thing as 3 pi over 4. And if you draw me the unit circle, negative pi over 2 to pi over 2 is this. This is negative pi over 2 to pi over 2. Quadrant 4 and quadrant 2. And if you look at 3 pi over 4, 3 pi over 4 is right over here. This is 3 pi over 4. Okay, this is 3 pi over 4. And there's a reason why that it is not inside this orange zone. It's outside. But can someone tell me what is the same thing as this 3 pi over 4 for outside?
135 degrees.
So this 135, that you know 135 is not inside here. So can someone tell, because this is in quadrant 2, right? Can someone tell me quadrant 2 for sine, is that positive or negative? Sine, quadrant 2, positive. So what is the reference angle for this case? So what is this angle in this case? And that will be your answer you're looking for. Anyone know what's the answer for, if this is 3 pi over 4, what is this one? That will be pi over 4. Don't forget, the whole thing is pi. So if this is 3 pi over 4, the green one, and then this will be pi over 4. So this answer in this case will be pi over 4. And the reason why this is pi over 4 is because in quadrant 3 pi over 4 is in quadrant 2. Quadrant 2 is positive for sine, so that's why we use pi over 4. Now, what happens if I change this to become 5 pi? So this will cancel out, and your answer is not 5 pi over 4. Can someone tell me where is 5 pi over 4 in a unit circle?
The third quadrant.
The third quadrant. So this is the 5 pi over 4 that we're talking about here. And can someone tell me in third quadrant, sine is positive or negative?
Negative.
So negative. So your answer in this case will be because 5 pi over 4, so the reference angle for 5 pi over 4 is still pi over 4. But since this is in quadrant 3, it will become negative pi. Okay, so this is your answer for that case. So be careful with this kind of questions because it can be really, really tricky. So for the cosine, cosine, make sure you know that it goes from 0 to pi. For sine, arcsine, or arctangent, it will be from negative pi over 2 to pi over 2. Okay. Oh, can someone see my screen? That someone can ask. Can you guys see my screen?
Yeah. Yeah.
Yeah.
You guys can see it, right? Now, if I give you arctan 10 of pi 6, what do we do with this is we can cancel this. We get pi over 6. This is arctan now. And if you look at the arctangent, it's pi over 6 between negative pi over 2 and pi over 2. Is pi over 6 between these two numbers? Yes, pi over 6 is between negative pi over 2 and pi over 2. So that means your answer in this case is pi over 6. So if you cancel those two and your angles came out to be right in between the selected angles, then it will be then you do not need to worry about taking which one. But what happens when I give you arctan of tangent of let's say 5 pi over 6? So these two will cancel. Okay. Unfortunately, 5 pi over 6 is not inside this range because it's outside this range. So you cannot take this. So can someone tell me where is 5 pi over 6 belongs to? What quadrant?
The second quadrant.
Second quadrant. So pi over 6 belongs to the second quadrant. Okay. And for second quadrant, tangent is what? Positive or negative? Second quadrant, positive or negative for tangent? It is negative, right? Because it is in quadrant 2. So can someone tell me what is this value is? If this is 5 pi over 6.
Pi over.
This will be pi over 6. So your answer in this case will be negative pi over 6. The reason why your answer here is negative pi over 6 is because for quadrant 2, tangent is negative. So that's why the value here should be a negative pi over 6. So very important case class, make sure you guys understand this, what quadrant is an angle belongs to, and then what is the reference angle you're taking, and then you put the sign. Okay, if it's positive, it's positive. If it's negative, it's negative. So this is what we talk about. This is very difficult here. So so make sure you guys know that if you have sine and arcsine, they will cancel each other off. If they are different, then you have to draw me the right triangle. So the right triangle is what we did before last time on Wednesday. So I'll give you a so I will do another example here. 6.6. So what we have on this 6.6 here. So again, this is how we do number 10 and 11. So if they don't have if they are not the same, so you cannot cancel this like that because they are not the same trigonometric inverse. So you have to use the SOHCAHTOA to do this and let tangent let theta become this whatever inside here, and you have to use your Pythagorean theorem or Pythagorean triplets to find it. So this is how we do question 10 and 11. This is what we did on last Wednesday. So what happens that if these are numbers, right? So what happens if that is not a number, like number 13 and 14? So the difference between question 10, 11, 12, and 13, 14 is 10, 11, 12, you have numbers inside this, the arcsine or arctan. But this time for question 13 and 14, the one inside the arcsine and arccosine here, they are no longer numbers, they are variables involved. So what happens if you have variables involved in this case? You just use variables. So last time we used numbers like 3, 4, 5, and so on. So this time we're going to use them in variable case. So we have a cosine of arcsine of 2x. So in order for us to find what is the algebraic expression for this case is, again, we will let theta become the arcsine of 2x. And then we will move this theta, arcsine over back there. So it becomes sine theta equals to 2x. Okay. So don't forget, if you move your arcsine around, you become the inverse. So my right triangle is not nice. So this is the triangle. This is the theta. And we know that sine in this case is opposite over hypotenuse. So that means that your opposite is 2x. Your hypotenuse is 1. Last time we used the triplet at 3, 4, 5, but unfortunately we cannot use the triplets here because this is a variable. So in order for you to find this adjacent, you have to use your Pythagorean theorem. So a squared plus 2x squared is equals to 1 squared. So you have to use your Pythagorean theorem, a squared, b squared, a plus b squared, c squared. So I move this over there. So a squared in this case is 1 minus 4x squared, because 2x times 2x is 4x squared. And I take the square root of it. Okay. So this is plus minuses. So in this case, your a in this case is plus minuses square root of 1 minus 4x. So now we can use this triangle to figure out what is cosine theta is. Because our arcsine of 2x is theta. So as you know that cosine is adjacent over by hypotenuse. Adjacent is this one, and it's going to be plus minus square root of 1 minus 4x over hypotenuse, in this case is 1. And as you know that anything over 1, we can erase. So your answer in this case is plus minus square root of 1 minus 4x. Square, oops, forget the square here. Forget my square in this case. Don't forget your square. So that is your how we do question number 13. So the difference between question 10, 11, and 13, 14 is that 10, 11, there are numbers here. So you can use your your triplets if you know your triplets. But unfortunately for question 13 and 14, you don't see any numbers. You're going to have x involved. So you have to use the Pythagorean theorem to do this kind of questions. So I want you guys to try question number 14 here. It's given us that tangent is the arc cosine of x over 3. So go ahead, try to do question number 14 in this case. Again, we let this become theta. So draw the triangles. Anyone? Anyone know how to use this triangle for this x over 3?
And your hypotenuse 3, and then your adjacent is x.
So x is your adjacent, and 3 will be your hypotenuse.
I know. Yep.
Okay, don't forget cosine is opposite, adjacent over hypotenuse. So how do you figure out your opposite here?
Pythagorean theorem.
Pythagorean theorem. So this is like a b here, right?
Yep.
So what is b in this case if you use Pythagorean?
Minus x.
Kelvin, I cannot hear you. Have press the space a bit longer. Anyone? What is your b in this case?
3 minus x.
Not 3 minus
And
x.
9.
9 minus
x squared.
X squared. Don't forget to square that. Okay, it's a squared minus b squared. So in this case, your b in this case is plus minus square root of 9, 3 squared minus x squared. So can someone tell me what is the answer for question number 14, tangent theta? So tangent theta is what over what? Opposite over by what? over by adjacent. So what is opposite and adjacent in this case?
Over x plus or minus 9 minus x squared. Square root of 9 minus x squared over x.
So it's plus and minus square root of 9 over 9 minus x squared all over by x. So this is your tangent theta. Okay. And the reason why that you got plus and minuses, it depends on what quadrant it belongs. Yep. Nope. Opposite over adjacent, not hypotenuse. So so the plus minuses is depends on what the theta here. If your theta is quadrant 1 and quadrant 3, then we use the plus. If your theta is quadrant 2 or quadrant 4, we use the minus, okay, because tangent is negative in quadrant 2 and quadrant 4. So this the reason why you got plus and minuses in your answer here. It depends on what your theta at. Okay. Anyone have any questions with this kind? Anyone have any questions? Okay. So make sure you guys know the difference between these two. And yes, this kind of questions will be asked in your test 3. Okay. So I will ask you this kind of questions in test 3. So this is the end of chapter 6. How do we do the arc sine and graphing them? And then how do you find using SOHCAHTOA? Very important. So chapter 7 is where you begin to use identities. Now this is the most important sections. And if you go to your pre-calculus next semester, you need to know this. This whole, what we call as the fundamental trigonometric identities, you have to know this. And yes, you also have to know this when you go to calculus 1, 2, and 3. So this is something that is called fundamental, very basic. We got 1, 2, 3, 4, 5 types of fundamental identities. One is called a reciprocal identities, which you guys familiar with this because sine is 1 over cosecant. Cosine is 1 over secant, tangent is 1 over cotangent, and then you reciprocate it. Cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. So this is the reciprocal identity we call. The next identity that we have is called the quotient identity. The quotient means division. So quotient identity is tangent is sine over cosine. Cotangent is cos over sine. So this is called a quotient identity. The next one we have is called a Pythagorean identity. So it's like a squared plus b squared equals to c squared. Sine squared theta plus cosine squared theta is equal to 1. 1 plus tangent squared equals to secant squared theta. 1 plus cotangent squared theta equals to cosecant squared theta. I think we talk about how we derive from this to the other two. Is you either divide everything here by sine squared theta. You will get into the 1 plus cotangent square equals to cosecant square. And if you divide everything here with the cosine theta, so 1 is sine, 1 is cosine, then you will derive it at 1 plus tangent square equals to secant square theta. So this is the Pythagorean identity. The next identity we have is called a cofunction identity. What is a cofunction identity? Cofunction is where you add two angles up. And if the angles came up to be exactly 90 degrees, then they are the same. So sine and cosine is cofunction identity to each other. Tangent and cotangent is a cofunction. Secant and cosecant is cofunction. A cofunction means that if you take these two angles and add them and you get a total of 90 degrees, then these two angles are the same. For example, for a cofunction identity will be like it's not giving me that. It's like, so we do the cofunction here. For example, is sine of 32 degrees. This is equals to cosine of 58 degrees. Because when you add this 32 and 58, you get 90. Okay. The cosine and cosine, same thing with tangent and cotangent. So tangent 32 degrees is the same thing as cotangent 58 degrees. And then secant and cosecant is the same. Secant 32 degrees is the same thing as cosecant of 58 degrees. So this is what we call as the cofunction identity. So that means these two angles, when you add them up, you get 90 degrees. Okay. And the last one we have is called the even and odd identity. So even and odd identity is used when you have a negative angles. And if you have, if the for cosine and secant, the negative will disappear. This is what we call as an even identity. Sine, tangent, cosecant, cotangent, when you have a negative, the negative actually move it up front. This is what we call as odd. I don't know what happens to my my PDF here. I cannot actually do anything with this. Usually I can write something on it. You know, I cannot do anything. So this is, so when you have even odd identity, your cosine and secant is called the even, and the rest of them, the sine, the cosecant, the tangent, and the cotangent is called the odd function. When I say even, means that if you have a negative, the negative will disappear. Okay. Odd means that if you have a negative of the angle, the negative will move it to the front. Okay, so this is called an even odd identity. So, so when you do 7.1, these 5 identities will be used a lot. So I will shortcut them. So reciprocal identity is called Ri. Quotient identity is called Qi. Pythagorean identity is called Pi. Cofunction identity is called Ci. Even odd identity is called EOI. So just, you know, short form them, easy for us to name them. So beside this kind of identity, so when you do the reciprocal identity, this is the identity that you have. You can actually always manipulate this kind of identity. When I say manipulate, means that if you got sine theta equals to 1 over cosecant theta, like the first one we have here, you can actually do like equation. So when you multiply both sides by cosecant theta, you will get cosecant theta times sine theta equals to 1. So this is also a reciprocal identity, but you just change the form of it. You just manipulate a little bit. So all this identity that you see here can be manipulated by like equation. If you multiply something on the same on one side, make sure you do it on the other side. Same thing with this case. So like example, the quotient identity that we have here, where we know tangent theta in this case is sine theta over cosine theta. So if you multiply cosine theta to that side, so cosine theta times tangent theta in this case is sine theta. So this is also a quotient identity. That means you can actually manipulate this. Same thing with the Pythagorean identity, but the Pythagorean identity is the one that we use the most manipulations here. So you see it in this section a lot. Like sine squared theta plus cosine squared theta equals to 1. I think we did this a little bit before. So I can write this in terms of sine squared theta. I just move it over there. So sine squared theta in this case is 1 minus cosine squared theta. So this is also a Pythagorean identity. And since this is a perfect square, so this is the same thing as 1 minus cosine theta plus 1 plus cosine theta. So this is also Pythagorean identity. So what I want to point out to you guys here is that your identities that you see in just this 7.1 is not just fixed like this. It actually can be manipulated, means move things around, like solve equations, factoring, and all these things. And it means the same thing to us. So this is very important class, and this is why this section 7 is so difficult. Is because a lot of students cannot manipulate this kind of identity. They just fix on this identity here. So make sure you guys, you have what I'm saying, you have to think outside the box in this case. Okay. So what is the useful? The most important thing is the Pythagorean identity. The Pythagorean identity can be only used if you see squares. So any questions that involve with sine square or cosine square or tangent square or secant square, you are only allowed to use the Pythagorean identity. Okay. And the Pythagorean identity is not used when you just have, it's not sine theta plus, let me cut down the square. Sine theta plus cosine theta. If you cut down the square, it's sine theta plus cosine theta equals to 1. This is not a Pythagorean identity. Okay, so do not forget to those. Oh, I can take the square off. I take the square with everything. That is not true. So so don't take out the square here. So Pythagorean identity can be only used when you have a trigonometry that is in square. Okay. The quotient identity is used when you want to write everything in terms of sine and cosine. Co-function identity used is if you see a 90 degrees minus theta or pi over 2 minus theta, depends on degrees or radian. Even odd identity is used when you have negative angles. You want to change it to positive angles. For example, is that for the even and odd identity, so if you want to figure out what is sine of negative pi over 3, so you can use the even odd identity. Sine in this case, because it is a negative, so you can take it out. So this is actually is negative sine pi over 3. So this is why the even and odd identity is used, is you want to change your from a negative angle that we have here to become a positive angle. This is a negative angle, and this will become positive. Can someone tell me what is sine pi over 3 is? What is sine pi over 3? Unit circle? Sine pi over 3? Square root of 3 over 2. And then you put the negative over there. So this is your, so sine negative pi over 3 is the same thing as negative 3 over 2. So this is the useful of your even odd identity. So again, make sure you guys know, not just memorize this like crazy. First, you need to know how to manipulate them, means move things around. 2, you need to know when to apply it. So applying and manipulating is more important than simply memorizing this one. Okay, a lot of students just doesn't know when to use it and how to manipulate it. So let's take a look at some examples we have on this section. So question number 2 in this case is you have to use the fundamental identity to figure out this cotangent square x minus cosecant square x. So when you look at this type of this type of questions, they want you to simplify it. So since they have a square here, means we can use the Pythagorean identity here. But if you look at the Pythagorean identity, we got 3 types. Should we use the first one, the second one, or the third one? Which one are we using for this? New one? Which one should we use? First one, second one, third one. So which one of these have cotangent and cosecant on square? Henry, Avery, Okay. Which one?
Would be the third one?
The third one, yes. So you're gonna do 1 plus cotangent. Sorry, mouse. 1 plus cotangent square theta equals to cosecant square theta. Now you need to manipulate this so it looks exactly like this. Can someone tell me how do you move these things around, like solving equations? You will get cotangent square minus cosecant square. So how do we do that? You take the cosecant square, what you do? Move it over there. So you will get what? Cotangent square minus cosecant square. But what happens to this one that you have here? You have to move it back to this side. So what happens when you move the one back to the other side? What do you get? Cotangent square minus cosecant square equals to what? Negative. So this is negative. So again, class, this is the difficult part in this class, is you need to know how to manipulate, change it. Okay. And this is like an equation, so you can always move things around. Anyone have any questions for me? This is super hard. And this is just first section of chapter 7. And you're going to use this a lot in this class. So question 3, secant square x minus 1 over by sine square x. So how do we simplify this? Again, they all are squares. So when they got squares, you can use your Pythagorean identity. Can someone tell me what is secant square x minus 1? Anyone?
One plus cotangent.
This is secant square x, not cosecant square x. So which Pythagorean identity should we use here for this case? One, number 2, or number 3?
2.
So it's 1 plus tangent square equals to secant square. So how can you make this as secant square minus 1? What do we do with this equation? Move it over there. Move your 1 over there, become minus 1, right? So what is secant square x minus 1 in this case? Hello? Anyone home? That will give us, anyone? Class, Kamal, Avery, Calvin. I'm worried about you guys now. That will give us tangent squares. You guys here?
Yeah.
Is this tough?
Yeah.
Yeah.
This is the reason why this is tough, is because you guys always look at the formula and you cannot manipulate, cannot change the form of it. So that's the reason why that you guys fix on this formula. So what we call as a fixed mindset. So we want you guys to really think outside the box and try to move things around, so you can always think outside the box. And this is something that is hard to teach, actually. And then, so we have the sine square x in this case. So what we need to do next with this is we will apply the quotient identity. So this, we can apply quotient identity. So you will get quotient is tangent is sine over cosine. So this will get sine square x over by cosine square x. And then we are still needs to divide by sine square x. So this is what we did for the quotient, is we take the tangent square to become sine over cosine square. And then the division is become divide by sine square x. And as we know that you can always change the division to multiply as long as you flip the second fraction. So this will become 1 over sine square x. And the sine square x and sine square x will be canceled. So what you get in this case is 1 over cosine square x. And 1 over cosine, if you look at your reciprocal identity, this is actually is secant square x. So you find out that the reason why this is tough here is because you have to apply a lot of identity here. Like this question 3, you have to apply Pythagorean, you have to apply quotient, and then at the end here, you have to apply the reciprocal identity. So these are the identities that is used a lot in this class. And usually if you look at the review for the test here, do you see anything that comes up from chapter 7.1, which we are in right now? If you look carefully here, we jump from chapter 6, and we only do 7.2 and 7.3. The reason why that 7.1 is not in this test is because 7.1 and 7.2 is the same thing. It's where they want you to prove. So if I come up in your test, I will say, I want you to prove that secant square x minus 1 over sine square x is equals to secant square x. And this is how you prove it. So this is what we call as proving identity. So that's the reason why that we will concentrate more on 7.2. But 7.1 that you guys did here is very similar to 7.2, but they don't tell you where you stopped, okay? Because you can stop over here, you can stop over here, you can stop anywhere you want. But in 7.2, they want you to say, I want you to prove all the way down to here. So this is how the proving identity is, and that's why it is tough. I didn't say this is easy. Okay? This is something that you need to really practice. Something I can, help you, but practice is the other one that you need to work on it, okay? Or spend some time. Again, we need to do some more of this. This is hard, but so can someone tell me what can we do with number 4? 1 minus sine square x over cosecant square x minus 1. So we're going to use Pythagorean identity here. So can someone tell me what is the Pythagorean identity for 1 minus sine square x? Oh.
First one.
1 minus sine square x. super tough. So this
Sine
is the,
square plus cosine square equals 1.
yep. So is sine square plus cosine square equals to 1. But I want 1 minus sine square. Can someone write this in the form of 1 minus sine square? What do you need to move?
Sine square.
So that will move over there. So become minus sine square. So what is 1 minus sine square x is?
Cosine square.
This is cosine square x. Yep. Now you do the one in the bottom. So repeat again. Cosecant square x minus 1. So using the Pythagorean identity, what do you get? So anyone know which one to use here?
Would it become cotangent squared?
Yep, this will become cotangent square x, which is the same as the last one. So we just need to move the 1 over there. So you get cosecant square minus 1. So that's why you will get cotangent square. Very good. So you need practice. That's why you guys need to do it. Then what we do here is the cotangent square can be applied with a quotient identity. So this will become cosine square x. And what is the quotient identity for cotangent x?
Sine over sine.
So this is cosine square x over by sine square x. Now, as you know that this is division. So this is the same thing as cosine square x times, because it used to be divide. Now I change it to multiply. Then what happens to your denominator? It used to be divided by cosine over sine square. What happens now is I change this to become multiply. What happens?
Becomes sine over cosine.
This will become sine square x over cosine square x. And what can we do here? The cosine square x will cancel. So what you got?
Sine square.
So this is your answer in this case. Tough? I didn't say this is easy. The first time I learned this, I almost cried. I can tell you right now, when I learned this in my high school, I almost cried. And the teacher says, I cannot teach you guys. I can only help you. I cannot teach. I cannot really, I can guide you. But then in the test, no, the teacher just looking at us, she cannot help me. So I have to there's a lot of things. I have to practice this a lot of time. So that's the reason why that you guys have to do the same thing here. So make sure you guys practice this because otherwise you will struggle here. Cotangent u times sine u plus tangent u times cosine u. Now, are we using Pythagorean theorem, Pythagorean identity for this case? Are we using Pythagorean for this case? Can we use Pythagorean?
No,
Why we cannot use it, Nukin?
there's no addition or subtraction.
We have addition here.
Oh, okay. Then I
That's an
guess there's
addition.
multiplication.
Nope. Anyone want to try?
Cosine. Okay.
Don't forget, Pythagorean theorem can only use when your trigonometric is what power?
Square.
The square. Do you see any square involved in question 5?
No.
No. But if you look at question 2, 3, and 4, they all have what? Squares, right? So when you see squares like this, Pythagorean. You don't see any square here, don't use Pythagorean. Okay, so that means Pythagorean is out. Cofunction is out because you don't see the 90 degrees of pi over 2. Even odd identity is out because you don't have a negative. So the only thing that the angle, the u here is positive, you don't have a negative. So the only thing we're going to use here is either reciprocal or quotient. So which one you think we should use here?
Reciprocal.
I'm sorry,
Reciprocal.
reciprocal of which one?
Cotangent.
What's the reciprocal of cotangent?
1 over tangent.
But is that the same as sine here?
No.
No, so we cannot cancel. Usually when you guys simplify means you try your best to cancel something, right? So we don't use reciprocal here. What can we use beside reciprocals? The only left is the what? The quotient identity. Can someone tell me? And quotient identity can be only used for cotangent and tangent. So can someone tell me what is the quotient for cotangent u?
Cosine over.
So it's cosine u over sine u. And don't forget, we still have a sine u here. You know what to do with it, right? So the class, this is usually I tell my students when the question wants to simplify. Simplify means cancellation, any reduce or make it smaller. Okay. Tangent u, what is the quotient identity for quotient u? Anyone?
Sine over cosine.
So this is sine u over cosine u. And the cosine u remains the same here. So what you can do now? What can we simplify? What can we cancel?
Sine u.
So the sine u for the first one, and which one of the second one?
Cosine u.
Cosine u. So what you left in this case is cosine u plus sine u. Now, can we use Pythagorean identity here to say this is equals to 1? Can we do that?
No,
Why not, Kelvin?
there's not a 1.
That's not what?
There's not a square.
Yes, that's not a square. So do not forget, class. Pythagorean identity can only apply if you see what? Squares. Then you can apply it. So in this case, your answer is cosine u plus sine u. So this is how we do this. So make sure you guys practice. You guys need to practice. So that's why you need to really spend some time here. And again, class, please utilize me or the Math Resource Center here. Otherwise, this test is going to be super hard. A lot of students it's going to be a very.
We can't hear you.
You're muted.
You're muted. David, you're muted.
Sorry, my internet is just cut off just now. So I'm back. You guys okay? Okay, it's connected now. You guys got it, right? You guys can hear me? Okay.
Crash.
Yeah, my internet got cut out. I don't know what happened. So it does happen. So yep, thank you. So so question 6, we'll do 6 and 7 and we'll stop. Question 6 is asking us to perform the indicated operation. So sine x plus cosine x squared. So this is question number 6 here. So so if you just remember this as x plus y squared, can someone perform foiling? Do you guys know what x plus y squared is? Anyone?
Yeah.
What's that?
Be sine x squared
So it's x squared plus
yx.
yx, and then or xy, and what else?
Plus x plus y squared.
And then how many xy do we have here?
2.
So it's 2xy, right? So this looks, number 6 looks exactly the same as what you guys do. So you have to square this. So what you get when you square this is x squared. So x squared in this case is what?
Sine x squared.
Sine square x plus 2xy, because we got 2 of them. So what is this gonna get when you get?
2 sine cosine.
Yep, 2 sine cosine, or cosine sine, doesn't matter. Plus what?
Cosine squared x.
Square x. Yep. So this is what you. So if you doesn't know how to do this, just pretend this is your x and y. So you for it or do. So if you know how to do this, then it's the same thing. But now you have to use your identity to do this. So which one can we apply your identity on this expression?
The first one.
Reciprocal, quotient, Pythagorean, cofunction, even odd, which one?
Pythagorean.
Pythagorean on which one?
Sine, that one, and the last one.
Yep, so sine squared plus cosine squared will actually give us 1. What happens to the 2 sine x cosine x? That one you just rewrite it. And we do have an identity for 2 sine x cosine x that you will learn in in last section 7.5. Okay, but now it's 7.1. We don't learn that yet. So this is how we do question 6. Is we for it, and then you combine your sine square and cosine square become 1, and that is your answer in this case. Tough?
Yeah.
This is difficult. Ooh, let's do this one. Now, before we do this, 1 over secant x minus plus 1, 1 minus 1 over secant x minus 1. So this is very difficult, and we're going to talk about this a lot in Wednesday class 2. So before we talk about this, let's do something similar. So we do 1 over x plus 1 minus 1 over x minus 1. So let's do this one first. And if you doesn't know how to do this one, I can guarantee you will not able to do this question 7. If you add or subtract fractions, the first thing you need to find is the LCD. Okay, so make sure you guys know that. So you need to know when you add and subtract fractions, if they are different denominators, you have to find your LCDs. Anyone know what's an LCD in this case? The least common denominator. So the LCD in this case will be x plus 1 and x minus 1, because they are 2 different denominators. So your LCD is a combination of those 2. And what we need to do next is you multiply. So this x plus 1, you are missing x minus 1. So we will multiply x minus 1. And as you know, like fraction, if you multiply something on the bottom, you have to multiply it's the same thing to the top. This one is missing x plus 1, so you have to multiply x plus 1 here. And again, you also have to multiply x plus 1 on the top. So what we have in your denominator is they are having the same denominator, which is x plus 1 and x minus 1. So if they're having common denominator, then we can add and subtract your numerator. So the 1 will be distributed, you get x minus 1 here. Now this one is tricky is because you are actually distributing your negative 1, because the negative goes to this. So when you're distributing your negative, you will get negative x minus 1, because negative 1 times x is negative x. This will give us negative 1 for next. You notice that x and the negative x will cancel. So what we have is a negative 2, x plus 1 and x minus 1. So this is how we do this kind of what we call as a rational expression. So this is similar to what we did on number 7. So we need to find the LCD here, because when you add and subtract fractions, if the denominator is not the same, common denominator. Can someone tell me what is the common denominator for this case?
Secant x plus 1, secant x minus 1.
Yep, it'll be secant x plus 1 and secant x minus 1. So this is missing which term?
Secant x minus 1.
So you will be multiply that missing term, secant x minus 1, to both sides. Up and down, sorry. What is missing on this side?
X plus 1.
So it's secant x plus 1. So you have to do it on the both top and bottom. So now your denominator is secant x plus 1 and secant x minus 1. Now what happens in your numerator, the one we distribute it? So you will get secant x minus 1. And this negative, like what we have over here, it goes to this negative 1. So when you distribute your negative 1 in there, you get what? Negative secant x minus 1. And what happens to the secant x you see on the top? They will zero up because one is plus and one is minus. So you end up with a negative 2, very similar to what we have here, right? Over by this secant x plus 1 and secant x minus 1. This is what we stop over here. But in this question, in this trigonometric function, we can perform more things. For example, you can FOIL this one out. Usually in this question, we stop over here. This is your answer. But over here, you can FOIL this one out. Can someone tell me what is the FOIL of secant x plus 1 and secant x minus 1?
Secant x squared.
Secant square x minus 1. Okay, don't forget, because there are 1 plus 1 minus, your middle term will cancel out. And then you will begin to use your Pythagorean identity on this friend of yours. Can someone tell me, if you look at your Pythagorean identity, which one will give us secant square x minus 1? The first one, the second one, or the third?
The second one.
So what is secant square x minus
1 plus tan.
This will become just tangent square x. Okay. So the secant square x minus 1, if you move the 1 over there, the positive 1 become negative 1. So secant square x minus 1 become tangent square x. And if you want, this can be written down as negative 2 times 1 over tangent square x. And we can use the reciprocal identity on this. Anyone know what is the reciprocal identity of 1 over tangent?
Cotangent.
So this will become a cotangent square x. So this is how we do this kind of question. Yeah, this is a super duper tough. Is when you have such things, we continue on this side by applying Pythagorean identity. And once you finish applying Pythagorean identity, you have to use the reciprocal identity to flip your 1 over tangent to become cotangent square x. And this is how you do question number 7. This is something that you will see this a lot in your tests and your homework. This usually we call you to prove the identity of this is equals to -2 cotangent square x. And this is how we prove it. You had to prove all the way. So 7.1 and 7.2 is very, very similar. So that's why you guys need to practice quite a little bit here. Very important stuff here. I'm going to take attendance, so make sure you guys go to the chat room and mark present here. Okay. Something that's quite important here. So I will give you some hint here, class. The hint that I will tell you here is if you have something square, for it. Okay, that's your hint. If you have addition and subtraction fractions, you have to find the LCD. Okay. If you have something in common, you have to factor it. Okay. So these are all the stuff that that the hint I will tell you here is. Make sure you know how to find. You know how to find the LCD and do your what we call as rational expression here. And if you have anything that is can be factorable, you have to factor it. So again, if you are not very good in factoring, you might have to struggle a little bit in this section, because like question number 8, they want you to factor. This is called a factoring. So you got sine square x, secant square x, minus sine square x. Let's finish the last one we're going to do here. So can someone tell me what can we factor on number 8? Anything in common that we can factor out? Anyone?
The sine.
So you can factor out the sine square x. And what happens when you factor out the sine square x? So you will get secant square x, if you factor that from the sine square x, secant square x, minus what happens when you factor out sine square x from sine square x? You get what?
1.
You get 1. Okay. And now we're going to apply Pythagorean identity on this case. Can someone tell me what is secant square x minus 1? We do this a lot.
1 plus tan.
Nope, that is secant, but I want secant square x minus.
Tan squared.
This is just tangent square x. Yep. So don't forget the 1. You move the 1 over here, so that's why you come tangent square x. So we will have, this is still sine square x. Now, this is one of your possible answers, sine square x times tangent square x. You can also apply reciprocal identity here if you want to. The reason why I say, if you want to, is because what is a reciprocal for tangent? Is sine over cosine. So you can just, then you multiply this by sine square x here. This is over 1. So multiply them straight across, you will get sine 4x over by cosine 2x. So this is also another answer. So you can stop here if you want to. Or if you want to continue using your reciprocal identity, you can stop over here. And if you want to continue and flip the cosine up using the reciprocal identity, you can write this as sine 4x times secant square x, because cosine, the reciprocal is secant. So there are so many ways you can write this question 8 form. So you can just stop over here once you apply your Pythagorean identity, or if you want, you can continue using the reciprocal, the quotient. This is the quotient identity to change tan to become sine over cosine, and then or you can just flip this cosine up to become secant. So there are so many answers. That's why when you read this question, it says that there is more than one correct answer in this case. It's because you can stop on here, or you can stop in here, or you can stop in the green one. So that's the reason why in the test, I do not like to come up with these kind of questions in the test, because you can stop wherever you want. That's why I want you guys to prove the identity. So when I say prove the identity, I will tell you where to stop. Is that stopping at the blue, at this one, or is that stopping at the blue one, or is that stopping at the green one? So that's the reason why that in your test, you will see your 7.1 home sections in there, because this is just to showing you how to apply all these identities to this section. And then later on, you will see this in question 7.2, where you start to prove it. That is the main part of this class, is to prove your identity. So we're gonna stop here. So so make sure you guys brush up your factoring. Try to factor basic stuff, and that will really help you here. We will continue the rest of this on Wednesday. So, and then this is something that you guys have to do. If you guys want to practice more this kind of work, I would recommend you to use your textbook and then go to the page. Remember, every textbook, if you look at my notes, these are your practice homework. I would recommend you guys to practice this, especially if you need more practice. 7.2 is the one that I strongly suggest you guys to do it. This is the one that you need to practice here. So we will be doing quite a lot of, we will concentrate more on 7.2 on Wednesday. That is very, very important here. Right, so that's it for today's class, which is kind of difficult here. Please, I recommend you guys to get some help, especially from me or from a Math Resource Center. This chapter 7 is a killing sections. Actually the whole chapter 7 is a killing chapter. So please get help from me or from someone else, okay, or the Math Resource Center.